Hello, my name is Cameron. I'm a member of the Penguineers programming team, and today I'm going to be explaining to you guys how to create a software stop for your robot this year in FTC Into the Deep. So one of the bigger problems this year was a lot of teams, they added that new rule. So the new rule essentially constituted your robot had to be within a 42 by 20-inch box throughout the whole match, and it couldn't really exit that. And a lot of teams ran into the issue of creating a mechanical stop that would hinder their movement, or they would have the drivers consciously remember, or they just wouldn't have their slide long enough to score. But some teams also opted for a software stop, which we will explain why is the optimal solution. So instead of creating a mechanical stop, which would hinder your movement in kind of all of the areas, you couldn't extend fully to get to the top basket, most likely. You might not even be able to extend to get to the second specimen deposit. We think that a software stop, which you could use encoder values to create, that would only stop your slide from extending when it's in that horizontal position, would allow for some leeway and be optimal, and that you stay within the rules, you don't take any penalties, while simultaneously being able to also score as many points as possible in the high baskets and the things that require more movement and couldn't allow for the mechanical stops universal nature. So I'm going to get into this starting with the hardware map. So we have a hardware map and we initialize all of our motors in it. But I'm just going to scroll down to the part where we kind of initialize our motors that control this. So initially you want to stop and reset your encoder. So what does that mean? In simple terms, kind of what it means is whenever you start your robot and start your teleop, it will move it will change the encoder values to 0. So it'll always reset them back to 0. So instead of having it kind of remember where the previous encoder values were from the last time your robot was on, it'll immediately reset them at 0, which is really helpful because sometimes maybe it'll remember where the encoder value was from last match, but maybe you moved your slide in the interim. In times maybe you're carrying your robot, you moved your slide, and you extended it, and then the encoder value is off, or just accumulation. These encoders aren't 100% accurate, and kind of the longer you run them, the more error they're going to accumulate. So whenever you reset that to 0 at the beginning, like we're doing here, that makes it a lot better for your robot and its accuracy over the match. So the next thing you want to do is just initialize them to run using the encoders. So that means it'll run with the encoders, it'll track the position, and now they're running and they're at 0 essentially. So now, you might be wondering, how do you implement this in teleop? So what we do is we use a series of conditionals in our loop. So obviously in teleop, the loop comes back and checks everything every, I believe, 25 or 50 milliseconds. And so what we have in here is an if statement that will check if our robot is within the dedicated constraints. And so the way we do this is we have an if the worm gear, which I should have explained this earlier, is the way our robot kind of works is we have a worm gear that rotates a C channel, and on top of that C channel is our actual slide that does the scoring. So our slide that would extend to pick up in the submersible, extend to drop in the bucket, or extend to do whatever it needs to do. And then, yeah, so the worm gear, and then there's a slide. So what we have is the worm gear position and the slide position, because two ifs simultaneously. Because if the worm gear is just facing horizontally, we don't want to stop our slide from moving. And if our slide's extended fully, we don't want to stop it from moving unless it's within that horizontal position. So we have this encoder value, which you'll get from trial and error. So what I would recommend is kind of, if you know telemetry data, I would use the telemetry data you get and kind of check the telemetry to make sure that it's within whenever it gets to that limit. So you display your telemetry data, you have a what's it called, a tape measure out next to it, and whatever values you get after about n equals probably 5 or 6 trials, then you kind of pull that and take the average, and then obviously excluding any outliers, and then use that value for whatever extension you get. So we found that this 2500 position was about where it gets kind of angled at about a 20 or 30 degree angle horizontally with respect to the ground. And we have our score slide position at 2100, which is a little bit under the limit actually. So this encoder value puts the robot at about 40 inches in total. which is good because we have that extra bit of leeway in the match just in case our encoder accumulates error over time. So this on its own would be pretty nice, and we could set the score slide power to 0 as you can see, but we also added a third condition in order for this to happen. So instead of just always setting the slide's power to 0 when it's beyond these limits, we added the ability for the user to actually retract the slide. So kind of before what we had is we had these two and it would set the robot score slide to 0, and then you would have to move that angle, that worm gear at an angle higher than 20 degrees or 2500 encoder value to get to be able to move it again. And well, that was nice when we were trying to extend fully. Sometimes we want to move our slide in and we want to have the freedom to do that. So we also added another condition on it that says if your gamepad 2 right stick is less than 0, which is our gamepad 2 right stick X is what controls our scoring slide. So if that's less than 0, we will also stop it. But if it's greater than 0, which means it's retracting, we're not going to do anything, and we're just going to have this else statement that just allows it to have the slide variable, like the slide move at whatever speed we set it to, with both our speed controls and our gamepad 2 right stick X. So yeah, that's about it for this video, and that's kind of a simple overview of a software stop you can use in your robot. And yeah, thank you guys for watching. It was great to see. If you have any comments, questions, you can place them in the comments below. If you can follow us on Twitter, check out our website, check out the first open house, which has a lot of resources on it. If you want to learn some more about programming beyond what I just posted in these videos, you could learn. There's Roadrunner documentation. There's all these great things, and we highly recommend checking it out. So thank you guys for watching, and yeah, that's about it.